This video discusses implicit differentiation. Under implicit differentiation, you will see equations written using both x and y terms, and we are going to find the dy by dx. So far, almost all the equations that we saw have been written as y equals f of x. We wrote dy by dx, and that was equal to f prime x, or in other words, you can write this as d by dx f of x. But under implicit differentiation, you are not going to see the equations that are written as y equals a function f of x. Instead, you will see the combinations of x and y written together. For example, think about an equation of a circle. X squared plus y squared is equal to 16. And if I would like to know the dy by dx for this equation, of course, it's not impossible to rewrite this equation subject to y and differentiate it afterwards just by using the traditional methods that we have discussed so far. However, when you have an equation like this, you don't need to subject y because it's going to be some additional work. Instead, you can straight away go ahead and differentiate these kinds of functions as well. That concept is going to be discussed under implicit differentiation. Actually, I would like to write down another, a bit more complicated equation. X squared plus y squared minus 4x plus 6y minus 5 equals 0. Let's say you would like to find dy by dx for this equation. Using the previous methods, such as writing it as y equals f of x, is going to be really tedious, because this equation is actually a quadratic equation of y. Well, of course, we can use the quadratic formula and still subject y. It's not an impossible task, but it's going to be really time consuming. Therefore, if you would like to find dy by dx for an equation like this also, the use of implicit differentiation will be very helpful. However, for both of these examples, implicit differentiation is actually not the only available option to find dy by dx, because subjecting y is always possible in both of these equations written. However, there can be some other situations like this one. Let's say I have x to the 4 plus 5y cubed minus 4x squared y to the 4 plus 5x square root y minus 6 square root x plus 7 equals x squared y. If you have an equation like that, subjecting y will not be that easy. Of course, I would say that for this equation right here, if I need to find dy by dx, maybe my only practical option available is implicit differentiation. Now we will look at a couple of examples. Let's say I would like to differentiate x raised to the n. I would like to differentiate that with respect to x. We already know that the answer for this one is n times x n minus 1. No difficulty arises there. Let's say instead of x to the n, I would like to differentiate y to the n. This time not with respect to y, because if I differentiate this term with respect to y, it will be just the same result. You're going to replace the x with y. Then simply your answer should be n times y raised to the n minus first power. However, what we are going to do is we are going to differentiate y raised to the nth power not with respect to y, but with respect to x. If you need to differentiate this term with respect to x, I'm going to use the chain rule, and I'm going to rewrite this term on the right hand side this way. dy raised to the nth power, of course that's what I have to differentiate, divided by, instead of dx, I'm going to write a dy, and then I will times that y dy over dx. By doing so, I didn't change the question given. On the left hand side, I have dyn over dx. On the right hand side also, I can consider that the dy's are cancelled like that. Then I just have dyn over dx. This is simply the chain rule. Now we know the answer for this part. I need to differentiate y raised to the n with respect to y. I can simply write down the result that I have already right here. So the answer is going to be equal to n times y n minus 1 for that very first part. But that's not all. I have to times that by dy by dx. Therefore, let me write down that term as it is. This times dy by dx. We will do a couple more examples. Let's say I need to differentiate sine x. I need to differentiate sine x with respect to x. We already know that the answer for this one is equal to cosine x. Instead of that, if I would like to differentiate sine y with respect to x, d sine y over dx, I will first write it down as d sine y over dy times dy by dx, simply the chain rule, because by cancelling off the dy's like that, I have gotten exact same d sine y over dx on the right hand side as well, d sine y over dx. Therefore, I haven't changed the question given. Now we can write down the answer for this problem. This is going to be equal to d sine y over dy, sine y differentiated with respect to y. That should be equal to cosine y. That times dy by dx. I simply have to write down times dy by dx. Just remember this pattern when you have to differentiate a function written in terms of y. In general, I will write down an equation for implicit differentiation this way. Let's say I would like to differentiate a function of y, dfy over dx. I need to differentiate a function of y with respect to x. According to the basic chain rule, I have the freedom to write it down as d by dy, the function f of y, times dy by dx. This is the equation that you need to remember when you go for implicit differentiation. That means, in general, under implicit differentiation, under this section, you are always going to see the functions in terms of y. If you have to differentiate a function written in y with respect to x, your first step is to differentiate that given function of y with respect to y itself, and then times that by dy by dx. Now we will look at a couple of examples. Here is your example number 1. Find dy by dx for x squared plus y squared equals 25. And also find the equation of the tangent drawn to the circle at 3, 4. This is a circle centered at the origin whose radius is equal to 5. I need to find the equation of the tangent drawn to this circle at 3, 4. Of course, a point is given to me. What I need is the slope. In order to find the slope, I will need dy by dx. Therefore, I would like to differentiate this given function right here. When I differentiate both sides of that with respect to x, the first term is x squared. We know how to differentiate x squared with respect to x. It will be just a 2x. That plus. I need to differentiate y squared. When you differentiate y squared with respect to x, it will be first differentiated with respect to y and then times that by dy by dx. Therefore, it will be 2y times dy by dx. On the right hand side, I need to differentiate the 25. When I differentiate 25, it's a constant, therefore it's going to be equal to 0. Now from this equation, quite easily, I can subject dy by dx. dy by dx should be equal to negative x over y. Because you can see that the 2's can be cancelled, and then I need to subtract the x from both sides, and after that I can divide both sides by y. Now dy by dx is available to us, and I have a point given 3, 4, and using the dy by dx value, I can actually find the slope of that tangent at that given point. That slope m will be equal to the dy by dx evaluated at that coordinate point 3, 4. Since dy by dx is equal to negative x over y, the slope should be equal to negative 3 over 4 because x is equal to 3 and y is equal to 4. Now we have a point and we have the slope. You can write down the equation of the straight line using the point slope form. If the slope is equal to m, if the point is x0, y0, then you know that the equation of the straight line is equal to y equals m times x minus x0 plus y0. Note that x0 for this example is equal to 3, y0 for this example is equal to 4, and m is equal to negative 3/4. Therefore, the equation of the tangent should be y equals negative 3/4 times x minus 3 plus y0, which is a plus 4. You need to simplify this equation a little bit and write it as a nice final answer. It will be equal to y equals negative 3/4 x plus 9/4 plus 4, which is going to be equal to 25 over 4. That's a complete answer for this problem. We will look at another problem which is a little bit more complicated than the previous example. This is your example number 2. Let's say we need to find the dy by dx from this function x squared plus y squared minus 6x plus 7y minus 2 equals 0. I simply have to differentiate both sides with respect to x. When I differentiate both sides with respect to x, this first term is going to be equal to just 2x plus I have to differentiate y squared. When you differentiate y squared, I need to first differentiate it with respect to y and then times that by dy by dx. When you differentiate y squared with respect to y, it will be a 2y and I need to times that by dy by dx. And then I have minus 6x. The derivative of 6x is equal to just 6. And then plus, I need to differentiate 7y. I need to differentiate it with respect to x. 7 is a constant, which I will simply write it as that. And then y should be differentiated with respect to x. No matter whether it is just a y or a more complicated function of y, first we differentiate it with respect to y itself and that times dy by dx. When you differentiate y with respect to y, it will be just a 1. That times dy by dx. Also simply remember, if you differentiate y with respect to x, it's going to be equal to just dy by dx. And then you have a constant 2. When you differentiate that, you're going to get a 0. On the right hand side, 0 differentiated with respect to x is equal to 0. Now, we can subject dy by dx from this equation. I need to isolate all the dy by dx on one side and move all the other terms to the other side. I will move the 2x and the negative 6 onto the other side. Then from the remaining terms, that means this term and this term, I can factor out the dy by dx. When I factor out dy by dx from the left hand side, from this first term, I will have a 2y. And then from this second term, when I factor out the dy by dx, I will just have a 7, close parenthesis. And this is equal to, now this negative 6, it will be a positive 6 on the other side, and this 2x, it will be a negative 2x on the other side. Now I can easily subject dy by dx. dy by dx should be equal to 6 minus 2x divided by 2y plus 7. I divided both sides by this factor, 2y plus 7. This is the final answer that I need for this example. Just a quick comment before I move on to the next example. Please note that for the 2 examples that we discussed, we didn't have any complicated product rules or quotient rules. However, you have to be very careful whether a given equation involving x and y terms has product or quotient terms. If you see such terms, please make sure to apply the product or the quotient rules accordingly. And also there can be composite functions. In such cases, please make sure to apply the chain rule correctly. Let's look at one more example. Here is your example number 3. For this example, I'm going to have some product terms. Let's say I need to differentiate x squared plus y squared minus 3x squared y to the third plus 4x y squared minus 5y minus 8x plus 7 equals 0. I need to find dy by dx for this equation. Now I will differentiate each of the terms in this equation with respect to x. When I differentiate x squared with respect to x, I will have a 2x plus I need to differentiate y squared with respect to x. First I have to differentiate it with respect to y, and that times dy by dx. Y squared differentiated with respect to y will be equal to 2y, that times dy by dx, minus 3, which is a constant, so I can factor that out. But now I have x squared times y cubed. It's a product. Therefore, I need to use the product rule. When I use the product rule, there will be a plus sign in the middle, and because this is a negative 3, since I have to distribute that negative symbol, I will open brackets, and then within brackets I will differentiate x squared times y cubed. When I do so, it will be x squared times the derivative of y cubed with respect to x. First I need to differentiate y cubed with respect to y, that times dy by dx. It's going to be 3y squared times dy by dx, that plus y cubed times the derivative of x squared, which is 2x. Please note that I simply used the product rule to differentiate this part. If this was a little bit difficult for you, you will need to revisit the discussion on the product rule. After that, I need to differentiate 4xy squared. Since 4 is a constant, let me factor that out, plus 4. I will open brackets and I will differentiate x times y squared using the product rule. It will be x times the derivative of y squared, which will be 2y times dy by dx, that plus y squared times the derivative of x, which is just equal to 1, close brackets. And then we need to differentiate this term. It's just negative 5y. When you differentiate that, it will be negative 5. The derivative of y with respect to x is dy by dx. And then I need to differentiate minus 8x, which is equal to negative 8. And that's equal to 0. Now we can subject dy by dx. In order to subject dy by dx, I need to keep all the dy by dx terms on the left hand side itself, which means all of these terms are going to stay on the left hand side, and I need to move the remaining terms onto the right hand side. In fact, we can do that simplification in one shot if you're a little bit good at simplifications. Just remember that when you move these terms, such as the 2x there, and this term, and also this term, their symbol should be flipped. You have to pay attention about moving this term onto the right hand side, because you shouldn't forget to times that by this negative 3 before moving on to the right hand side. Since all of those yellow terms are going to stay on the left hand side, I can factor out a dy by dx from those terms on the left hand side. Let me open brackets. From this term, when dy by dx is factored, I just have a 2y. From this term, after distributing this negative 3, once dy by dx is factored, I will have negative 9 x squared y squared, and then I have this term right here. When 4 is distributed, it will be 8 times x times y times dy by dx. Since dy by dx is factored out, it will be plus 8xy. And then I have this term right here, negative 5 dy by dx. I will just write a negative 5 since dy by dx is factored out. Close brackets. All the dy by dx terms are now taken care of. Then I need to move all of those red circled terms onto the right hand side. I can just freely move any term first. Let me go ahead and move this negative 8 to the right hand side. It will be a positive 8 on the right hand side. Then I will move this y squared term to the right hand side. Please do not forget to multiply that by the positive 4 before moving on to the right hand side. So it's positive 4y squared on the left hand side, which will move on to the right hand side as negative 4y squared. The next term that I should move on to the right hand side is this term, and I should multiply that by negative 3 before moving on to the right hand side. When I multiply that by negative 3, it will be negative 6xy cubed on the left hand side. When I move that onto the right hand side, it will be positive 6xy cubed. And then I need to move this positive 2x on the left hand side into the right hand side. It will be negative 2x on the right hand side. Now we can easily subject dy by dx. All I have to do is to divide both sides by this complete factor. When I do so, I get dy by dx equals 8 minus 4y squared plus 6xy cubed minus 2x. All of that's divided by 2y minus 9x squared y squared plus 8xy minus 5. That's the final answer expected for this problem. Here's your example number 4. Find dy by dx from 2 sine 3y minus 5 x minus 1 everything squared plus y minus 4 everything squared equals 2. If I differentiate both sides of that equation with respect to x, there's this 2, which is just a constant, that times the derivative of sine 3y. If I differentiate sine 3y with respect to x, the first step is to differentiate it with respect to y, and that times dy by dx. When I differentiate the sine 3y with respect to y, it will be cosine 3y times 3 times dy by dx. Please do not forget the times 3, because that's how we differentiate sine 3y with respect to y according to the chain rule. And then I have this minus sign, minus, and I will factor out the 5 since it's a constant, and then I need to differentiate x minus 1 everything squared. Using the power rule, I can easily differentiate that. It's going to be a 2 times x minus 1 raised to the first power. And then we need to differentiate the stuff inside the parentheses. When x minus 1 is differentiated, it will be just a times 1. And then I have this plus sign right here, plus I need to differentiate y minus 4 everything squared with respect to x. First I will differentiate that term with respect to y, and then times that by dy by dx. When you differentiate it with respect to y, once again using the power rule, it will be 2 times y minus 4 everything raised to the first power times, and then we differentiate the stuff inside the parenthesis. Please note that we are still differentiating with respect to y. When you differentiate the stuff inside with respect to y, it will be just times a 1. But we are differentiating all of that with respect to x. Therefore, you need to times that by dy by dx. On the right hand side, 2 is a constant. When you differentiate that, it will be equal to 0. Now we can easily find dy by dx. I will keep all the dy by dx terms on the left hand side, this term and this term, and then I will move the remaining term onto the right hand side. This will be moved to the right hand side. Now from the 2 yellow highlighted terms, I can factor out dy by dx. Then from this first term, I have 2 times cosine 3y times 3, which simplifies to become 6 cosine 3y. From this second term, I need to factor out plus 2 times y minus 4. close brackets. This should be equal to, the right hand side will have this term as a positive term, 10 times x minus 1. Now from this equation I can easily subject dy by dx. We get dy by dx equals 10 times x minus 1, all of that's divided by 6 cosine 3y plus 2 times y minus 4. That's a final answer needed for this problem. Alright, now you know what is implicit differentiation. If you have any questions, please feel free to let me know. Thank you so much.